Now, in the previous video, I think we completed up to here. Now we will discuss about the each purpose of an embedded system. Okay. Now, the six different purposes of the embedded system are: first one is data collection, storage, or representation. Second one, data communication. Third one, data or signal processing. Fourth one, monitoring. Fifth one, control. And sixth one, application specific user interface. So the first one is nothing but the data collection, storage, or representations. Now the purpose here is the data collection. We need to collect the data, we need to store the data in a particular place, and we need to represent the data in various formats. So performs data acquisition of data from the external world. That is the first one. Second one, the collected data can be either analog or digital. Now, you know very well the information which is available in the nature is always analog, not in digital. Okay. So the collected data which can be either analog or digital. Now, the data collection is usually done for storage, analysis, manipulation, and transmission. So once we collect the data, we need to store the data at a particular place. And after storing the data, we need to perform some various analysis techniques on the data, and we can manipulate the data. And once it is done, finally we can transmit the data from one place to the another place. The collected data may be stored directly in the system, or it may be transmitted to some other systems, or it may be processed by the system, or it may be deleted instantly after giving a meaningful representation. So that means the collected data, which can be stored directly in the system, or it can be transmitted to any other system, or it may be processed by the system, or it may be deleted instantly after a meaningful representation to the data. Now, this is the digital camera for image capturing or storage or display. So that means what this is an embedded system. So before capturing the image, the nature is analog. Okay. So once the image is captured, there is a pixel A to D converter which converts that information. So picture from analog to the digital, and that can be stored in the memory. So we can perform some various manipulations on the image. So that is nothing but processing. So once the processing is done, it can be stored in the space, or we can transmit that image. Next, second one, the data communication. So what do you mean by data communication here is communication is nothing but the transferring of data from one place to the another place. So embedded data communication systems are deployed in applications ranging from complex satellite communication systems to simple home networking systems. So the embedded data communication systems are dedicated for data communication. So the data communication which can happen through a wired interface like Ethernet or RS-232 or USB Universal Serial Bus or IEEE 1394 Firewire or wireless interface, which can be wired interface or wireless interface. Wireless is nothing but Wi-Fi, GSM or GPRS, General Packet Radio Services, Bluetooth or Zigbee. We can use any wireless interfaces uh, from these, and we can use any wired interface from these. Okay, network hubs, routers, switches, modems, etc. are the typical examples for dedicated data transmission embedded systems. So it can be a router, it can be a hub. Hub is nothing but there is a central controller. To that central controller, the number of devices are connected. If any device wants to communicate with another device, so it can be communicated through the hub. Okay, like modems, modulator, or demodulators like that. Okay, so these are the examples of the dedicated data transmission embedded system. So the picture which is shown here is nothing but the wireless network router for data communication. Next one, data processing. So once the data is captured and it is stored in a place, so we need to process the data. We need to process the data. So the embedded systems with signal processing functionalities are employed in applications demanding signal processing like speech coding, synthesis, audio, video codec, transmission applications like so processing the audio, processing the video, and the transmission applications. Okay, so we can have the embedded systems with the signal processing functionalities, and the computational intensive systems. These are the examples for processing the data and employs digital signal process. So there is a separate processor which is going to process the data or signal. So that is nothing but the digital signal process. So that means the embedded systems are using the digital signal process for data processing. Next, fourth one, monitoring. So monitoring is nothing but observing. So the embedded systems coming under this category are specifically designed for monitoring purpose. So this is a patient monitoring system, so which is going to monitor the heart rate, SpO2 levels, like etc. So they are used for determining the state of some variables using the input sensors. So they cannot impose control over the variables. Okay. So ECG, if you take ECG machine for monitoring the heartbeat of a patient, is a typical example of the system. ECG, electrocardiogram. So the sensors used in the ECG are the different electrodes connected to the patient's body. So once the electrodes are connected to the patient's body, so they acquire the heartbeat. They acquire the heartbeat. Okay. So measuring instruments, any measuring instrument like CRO, digital multimeter, logic analyzer, etc., used in control and instrumentation applications are also the examples of the embedded systems for monitoring purposes. These are the systems which are used only for monitoring the some variables by using some sensors, by using some input sensors. Next one, control. So the embedded systems with the control functionalities are used for imposing the control over some other variable according to the changes in its input variables. Okay. So the embedded systems with control functionality contains both sensors and actuators. So what do you mean by sensor? Sensor is a device which can convert one form of energy into the another form of energy. So sensors are connected to the input port for capturing the changes in the environmental variable. So the actuators connected to the output port are controlled according to the changes in the input variable to put an impact over the controlling variable to bring the control variable to the specified range. The best example here is the air conditioner. So air conditioner is for controlling the room temperature. Okay. So air conditioner contains a room temperature sensing element, which may be a thermistor and handheld unit for setting up the desired temperature. The air compressor unit acts as the actuator. The compressor is controlled according to the current room temperature and the desired temperature set by the end user. Next, the last purpose here is the application specific user interface. So the embedded systems which are designed for the application specific application, which contains the application specific user interface rather than the general standard user interface like keyboard or display units, etc. So these are aimed at a specific target group of users. The mobile handsets, control units in industrial applications are the example for this. Okay. So that's all. This is about today's video.